Dear friends, once again welcome. Let's now discuss about the problem on transformation matrix. The problem statement is a point P is attached to a frame FNOA is subjected to the following transformations. Find the coordinates of the point relative to the current moving frame at the conclusion of transformations. Okay, so we have to identify the transformation is either with respect to the current moving frame or the reference frame. So it is, let's start solution. So here the transformations are with respect to current moving frame. Okay, and then there are three transformations. First one, rotation of 90 degree about the z-axis, followed by a translation 4 minus 3 then 7, then followed by rotation of 90 degree about the y-axis. Okay, so the first one we denote by r z 90 degree, second one trans, and we write coordinates 4 minus 3 then 7, then third one again rotation about y-axis here, and the rotation is how much? 90 degree. Okay, and the sequence of transformations are what? 1 2 3, and here the transformation are with respect to current moving frame. Okay, so what we have to do, we have to post multiply. There will be post multiplications. Okay, what is the meaning of this? Okay, so firstly we need to write the new coordinates p and p new, and is equal to suppose we have here the old coordinate, and that is here what? Better to write in the form of f new here, better to replace p by f. Okay, f means the new frame, and f old, and that is what? f NOA, and is equal to what? It is given in transpose form. So 7 3 1 in transpose form. So if you remove this t, then you can write in matrix form 3 2 1. मीन्स क्या हो जाता है, आपका रो कॉलम में चेंज हो जाता है. ओके, coming back, what is the meaning of post multiplications? Okay, so what you have to do, f new is equal to f old, then the post multiplications of what? So right here first transformation, I am writing here the first transformation, this one, then post multiply the second transformation, then post multiply the third transformation. Okay, and the post multiply the given point. This is what? The given coordinates. Okay, and how to write t1 here? So rz, and see the sequence of multiplication here. The what is the note here? The sequence of multiplication is same of order of or sequence of transformations. Okay, so now at this stage we no need to worry about the sequence of multiplications, because the transformations are performed with respect to the moving frame. If with respect to the reference frame, then what is, then क्या करना होता, हमें प्री मल्टीप्लाई करना होता. Suppose if in case of transformations with respect to the reference frame, then how to write this matrix equation in the transformation form? So f new is equal to here, and f older we need to write here. Then the pre-multiply of what? Pre-multiply means we need to write here the first transformation, then second transformation, then the third transformations. Okay, and the sequence of multiplication is just a reverse of the sequence of transformation. So this is in the case of transformation with respect to the reference frame. Okay, now let us solve here. Our focus is here. Let us solve this. So this is equal to what? Once again we are writing here. So it is f new and rz 90 degree multiplied by trans, and what are the coordinates? So coordinates are here 4 minus 3 7, 4 minus 3 7, and then again rotation upward to y, and it is 90 degree again. Okay, then multiplied by the given coordinates f and OW. Okay, and better to write separately what is RZ 90 degree. Okay, and there is a multiplication of rotation, and means a rotation matrix, then translation, then again rotation, and the given coordinate frame. Okay, and what about the size of matrix? So rotation matrix can be written in 3 into 3 form, and the translation matrix 4 into 4, rotation again 3 into 3, and this is what? So 3 into 1. Okay, so then what is required? Our requirement is here what? We need to convert it into 4 into 4, and this same here we need to convert it 4 into 4, and this we need to convert 4 into 1. So then why? So that we can multiply the matrices and can know the and effector position and orientations. Positions means what is x, y in case of 2D, in case of 3D, z also. Orientation means theta means theta 1, theta 2, theta 3. Okay, like this. So that's why focusing on this requirement. So RZ 90 degree. ठीक है. So we can write it how RZ. Rotation is about Z axis of 90 degree. Okay, so what is the meaning of this? So meaning of this is, suppose this is our frame, okay, and x, y, z, and suppose the moving frame is coinciding initially, and n, o, a. So this is the initial stage, initial frame. After rotation about z axis, okay, so it becomes like it becomes x, y, z, and x, y, z is what? The reference frame, and n, o, a is what? The moving frame. Okay, so it becomes rotation about z. So that's why a आपका यहीं पे रहेगा. Okay, and o will be here, somewhere here, but n will be here. This will be n. Okay, so this is after you can say the first transformation. Okay, so how to denote it? By matrix. So what we can do here, rotation about z. So क्या हो जाएगा? Rotation about z. So there will be initially, suppose 3 by 3 matrix we have. Okay, then the last element will be 1, and this will be what? Then ये क्या हो जाएगा आपका? C theta minus S theta, here S theta, here C theta, and other elements will be 0. Okay, so this is the rotation about z axis, and theta is what here? Theta is here 90 degree. Okay, so this can be written, but here what is our requirement? Our requirement is to convert it into 4 into 4 matrix. So this we are going to convert. So क्या करना पड़ेगा? C theta here minus S theta, then 0, S theta, C theta, 0, 0, 0, 1, and क्या करना है? We have to add here, add one more column, here add one more row. ठीक है, so क्या करेंगे? one more row, and but another one, this one will be 1, and it's corresponding, all the elements of column wise will be 0. All the elements corresponding to this one will be 0. Then it becomes 4 into 4. Okay, so what we are doing here? We are maintaining the homogeneous matrix, means we are converting 3 by 3 matrix into 4 into 4, so that we can multiply all the matrices. Okay, so this we have done. Okay, let us put the value. So RZ here, RZ 90 degree is equal to what? So C 90 cos 90, here cos 90 minus sin 90, 0, 0, here sin 90, cos 90, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1 here. So it is equal to cos 90 is equal to what? So it is equal to 0, and sin 90 is equal to 1. So it becomes 0 minus 1 0 0, and here 1 0 0 0, here 0 0 1 0 0 0 0 1. Okay, the next, this is the first transformation. Okay, next transformation is translation. Translation of what? 4 minus 3 then 7. And how to write it? This is translation along x axis of 4 units, y axis of minus 3 units, z axis of 7 units. Okay, so how to write it in the transformation form? Okay, and it is pure, it is what? It is the pure translation. It is pure translation. Means no rotation occurs here. Okay, so how to write this in the matrix form? So it will be 4 into 4 matrix, 4 into 4 matrix, and as we know, the last row is dedicated. Last column, this one, it is 1 2 3 4. Okay, so the column name 4 dedicated for the vector matrix, or position vector, you can say, for position vector. Here position vector. So what is your position vector? 4, here 4, then minus 3, then 7, then 1. And what about the corresponding value of 1 as per the corresponding value of 1 row wise will be 0 0, all elements. Okay, and what about this one, this one, this one? Means 3 by 3. This is what? 3 by 3 matrix. This is rotation. Okay, rotation matrix, and the size is what? 3 by 3. So here rotation matrix will be unit matrix. Okay, so what is the meaning of this? यहाँ पे क्या हो जाएगा? हमें एक यूनिट मैट्रिक्स लिखना पड़ेगा. So that can be written here is equal to then 1 0 0 4, and it will be 0 1 0 0 0 1. So this part is done. This part is done. Okay, this is what? Unit means R3 into 3. Okay, and 4 minus 3 and 7 1 0 0 0. So this is the translation matrix. Now next one, the third transformation, that is what? That is rotation about y of 90 degree. So this can be written here 0 0 1 0, then 0 1 0 0, then minus 1 here, 0 0 0, then 0 0 0 1. Okay, now, and the last one, the point, the given point PNOA is equal to what? So it is 7 3 1 and 1. So that's why 4 into 1. 4 is what? 4 is what? 4 is here the rows, the number of rows. So here 4. 1 is what? Column. So it is 1. So in this way, now we can write all together P new, sorry, again F new, and the first one, let us come to this one, sequence. So the RZ90 we have to write, RZ, this we have to RZ90. So first one RZ90 here, that I'm going to write here 0 minus 1 0 0, here 1 0 0 0 0 0 1 0 0 0 0 1 here. Then next matrix of what? Translation matrix. So that is written here 1 0 0, and here 4, then 0 1 0 minus 3 0 0 1 7 0 0 0 1 here. Okay, next is what? Next is rotation about 90 degree, y-axis of 90 degree. This we can confirm here once again. So rotation about y 90 degree. So 0 0 1 0 here, 0 1 0 0, then minus 1 0 0 0, then 0 0 0 1 here. Then we have to write the given coordinate. So that is what? The given coordinate is here 7 3 1. Once again confirm it, 7 3 1. From the, yeah, from here we can see 7 3 1. 7 3 1 1 here. Now let us multiply it. So what we have to do? I'm going to multiply from here, from right to left. Means firstly, there are 4 matrices. Suppose this one, first, second, third, fourth. So I will multiply first 3 into 4. Okay, then what will be? What I will get will be multiplied by the second one. Then what I will get will be multiplied by the first one. So this sequence I'm following. So what we get at the last? So what we get ultimately after multiplying these 4 matrices, we get 0 5 0 1. The new position F new, or you can say these are the new coordinates of the AND effector. Now let us visualize this through the software RoboAnalyzer. It is for 3D model robotic motion visualization. If you type RoboAnalyzer in Google, you will find then the free version one can download. I have downloaded here, and this is the software. I'm clicking this, then the main software RoboAnalyzer for the robotic motion visualization, and in which there is HTM module. If you see the cursor, HTM module means homogeneous transformation matrix module. Homogeneous transformation matrix module, and by clicking this, I am getting this. Okay, so let us visualize this. Okay, so what was our point? Means a sequence of multiplication. So our sequence of multiplication was the first okay, so our sequence of multiplication of the transformations was the first rotation about. If you see this, uh, firstly, what is this? So there are two coordinate systems. One can see here. The bigger one is the reference frame, and the smaller one you can see, and both are coinciding initially. So this one is smaller one, means this is the x, y, z coordinates of the moving frame. And what about this is x, this is y, this is z for the fixed coordinate system. Okay, now what was our first transformation? So that was, if you see right side and see the translate and rotate. So first transformation was as per the sequence. So that was the rotation about z axis of 90 degree. Okay, so let us rotate. This is the first transformation. Okay, so what was the second? So second was the translation, and the coordinates were 4. See my cursor, -3 here. The last one 7. Then I am translating here. Okay, so it got translated, and one can see the rotation matrix just below of this means right side. See my cursor, and just below also see the sequence of multiplication of the transformations. Okay, so R1, then T2 means transformation 2, and in the form of translation. Then third was what? Again rotation about y by 90 degree. So rotating it. Okay, so this was the third one. Okay, and what about the point? The point को क्या कर रहे थे हम? Last में multiply हो रहा था. So what was the given point? So that was 7, 3, 1. Okay, and to visualize it, let us click the translate button. Okay, so in this way we have visualized the motion of the coordinate systems. And see, if you see the last column of this matrix, 4 into 4 matrix, this is the homogeneous transformation matrix, and one can match the answer. Okay, so what was that? 0, 5, 0, 1 means in x direction 0, y direction 5, and z direction 0. Okay, and this is the means for scaling. Our focus is only x, y, z. Okay, so this is confirmed by this visualization. You can say the graphical representation also we can do, or through our analytical approach by multiplying the matrices. Okay, that is also confirmed. You can see here 0, 5, 0. Here also 0, 5, 0. So with this, thank you.